Day 13 of 365. Here's something that should make you uncomfortable. Before your browser sends a single HTTP request, before any firewall inspects port 80, your machine has already fired off a DNS query, and DNS was designed in 1983 for a network where everyone was assumed to be friendly. That trust assumption never went away, and attackers know it. Today you'll trace exactly where DNS breaks, learn to spot tunneling in raw logs, and lock down resolution on both Linux and Windows. Let's go. First, the resolution chain. Draw this in your head. Your stub resolver asks a recursive resolver. The recursive asks a root server, which points to the TLD server for .com, which points to the authoritative server for the domain. 5 hops. Every single one is an attack surface. The recursive resolver can be cache poisoned with forged responses. The root and TLD can be hijacked via BGP or any cast route manipulation. The authoritative server can be compromised to forge answers outright. 5 hops, 5 distinct attack classes. Defenders who only watch web traffic never see any of it. Let's verify trust where it actually exists. DenSec. Run dig plus densec cloudflare.com. Look for the add flag in the response. That's authenticated data, meaning the signature chain validated. DenSec works as a chain of trust. Each zone publishes a DNS key, the parent zone signs a DS record that hashes that key, and every record set carries an RSIG signature. With DNSPython you can walk this programmatically, fetch the DS, DNS key, and RSIG at each delegation boundary and verify the signatures link all the way to the root. No add flag means nobody's checking the math. That's where forgery lives. Now the fun part, catching DNS tunneling. Attackers encode stolen data as base 64 subdomains, so a 7f3k9.xfil.evil.com is actually a chunk of your database leaving the building over port 53. Volume-based blocking misses the smart ones who go low and slow. So hunt on signal, not just volume. On Linux, parse your bind query log, awk through /var/log/name/query.log, compute per client query rate and average subdomain label length. Normal domains are short and dictionary-like. Tunnels are long and high entropy. Add a Shannon entropy check, random-looking labels score high. Rank the table, and the exfil channel floats to the top in minutes, no CM required. Windows Shop. Same hunt, different source. The DNS client logs to an operational event channel, event IDs 3008 and 3020 capture queries and responses. Pull them with PowerShell, get WinEvent, log name, Microsoft Windows DNS client/operational. Extract the queried FQDNs, then calculate label length distribution and queries per minute per source host. Flag the outliers, the one workstation sending 40 queries a minute to subdomains averaging 30 characters is your beacon. That's a copy-paste tunneling detector for a Windows-heavy environment, and it runs entirely with built-in tooling. Detection is half the job, now harden resolution. 2 goals, validate answers and encrypt the path. On Linux, systemd resolved does both. edit/etc/systemd/resolve.conf, set densec equals yes and DNS over TLS equals yes, then restart. Verify with resolvectal status, you want densec supported and a duty-capable resolver listed. On Windows 11, enable DNS over HTTPS via settings or push it through group policy and the DO registry keys under the network interface. Now your queries ride encrypted HTTPS instead of clear text UDP that anyone on path can read or rewrite. Prove it actually worked, don't trust the config, verify the wire. With DO or .dot enabled, run tk-dump in port 53 and generate some lookups. If encryption is enforced, that classic clear text port 53 UDP traffic should vanish. Your DNS is now flowing inside TLS on 443 or 853 instead. On Windows, confirm with nslookup that resolution still succeeds and resolve DNS name shows answers. Seeing port 53 stay quiet is the difference between a config you hope works and one you know works. Day 13 done. The takeaway: DNS touches every connection first, trusts by default, and most defenders never watch it, so trace the chain, hunt the logs for length and entropy, and encrypt the path. Subscribe for day 14.